Okay, so we are asked to find the minimum distance from the of the point 3 comma 0 from the graph of y equals root of x, and to be precise it is y equals positive root of x. All right, because positive negative root of x is not a function. So for those of you who don't know what the graph of y equals root of x looks like, it's just the graph of y equals x squared deflected across the line y equals x, and with this parabola removed, with this side of the parabola removed, because if that would be there, then this would not be a function anymore. So without wasting any time, let's just focus on the problem. So this is a problem from the channel Black Pen Red Pen, and he used derivatives to solve this, but I am going to use simple algebra, including the completing the square formula in order to find the answer. So let's begin. So what do we know? Essentially, we know that if there is a point on this graph that is some distance away from this, the formula for that one, the coordinates should be x comma root of x, because y equals root of x. So now let's use the distance formula in order to find the distance between this point x comma root of x to 3 comma 0. So what's change in x? That's x minus 3. What's change in y? That's root x minus 0 minus 0. That's just root x. So what is the distance? Well, the distance is just the square root of, and the positive square root of, or the principal root of, x minus 3 the whole squared, or the change in x the whole squared, plus change in y the whole squared. And let us change the color. Now this is just going to be the square root of, let's open the brackets, x squared plus 9 minus 6x plus x, which is just root of x squared minus 5x plus 9. After this, we are going to complete the square in order to find the minimum value of this thing right over here, x squared minus 5x plus 9, the minimum value of this, because the minimum, if we put the minimum thing inside this root of x, the square root, we are going to get the minimum value, right? So now let's try to find the minimum value, and for that I'm going to use the completing the square thing. So in order to complete the square, I'm going to write it as x squared minus 5x plus 9, this expression right here, as a square. So x squared minus 2ab plus, let's see, 2xb plus b squared. Okay, so x squared, I know that, minus 2x, what is b here? Minus 5x equals negative 2bx. So the b thing right over here is essentially going to be 2.5, right? Now we can complete the square. We know the first term, that's x, and the second term, that's y. That's 2.5. So we can write this whole thing right over here as the square root of x squared minus 2 times 2.5 times x, and because this is the middle term, we can add the square minus 2.5 the whole square plus 9. Now let us continue downwards. Okay, so we are continuing from here. So that's a square here, x minus 2.5 the whole square, the square root of x minus 2.5 the whole squared minus 2.5 squared plus 9. So 2.5 squared is, I suppose, 6.25 minus 9, that's 3.75, I guess. 9 minus 6.25 is 3.75. So x minus 2.5 the whole square plus 3.75. or essentially you can think of it as 9/4, I guess. By 2, yeah, 9/4. So that's 9/4. Now we can write it as root of x minus 2.5. Now what is the minimum value? Well, that happens at x equals 2.5, right? Because if it is less than 2.5, x is, the value of x is less than 2.5, this is gonna be positive. This whole thing is going to be negative, and the square will be positive, and this will increase the value of this. The minimum is reached when this thing x minus 2.5 squared is 0. So when does that happen? When x equals 2.5. So that's the point. And what's the y value at that point? That's root of 5/2, root of this. So essentially, to answer the question, the minimum distance, or the point that has the minimum distance, is 5 or 2.5 comma root of 5/2, that's essentially root of 10/2, and we are done. That's the answer.